There are mining equipment manufacturers that make one category of machine exceptionally well. There are others that make two or three categories competently. And then there is Komatsu, a company that makes haul trucks, bulldozers, wheel loaders, excavators, drills, and underground equipment, all at the highest production scales. All supported by a global dealer network and a service infrastructure that no other manufacturer can match in breadth. Komatsu is the most complete mining equipment manufacturer in the world. Its approach reflects a comprehensive understanding of mining operations. This understanding comes only from supplying every element of the production chain. The Komatsu PC8000 is this company's entry at the top of the excavator category. An 800-ton class backhoe excavator whose development reflects Komatsu's specific engineering priorities, not just maximum performance, but the best balance of reliability and efficiency. These priorities produce a machine that is a genuine competitor at the highest levels of surface mining loading. But the PC8000 story is more interesting. Komatsu's path to building an ultra-large hydraulic excavator was not direct. It involved strategic acquisitions. It included the acquisition of Letourneau Technologies and a competitive dynamic with Hitachi, who is both a direct competitor and occasionally a collaborative partner. Understanding this context is part of understanding the PC8000. Its design choices are made in the context of Komatsu's specific strengths and competitive positioning. Komatsu's complete portfolio creates an opportunity for the PC8000 to be not just an excellent excavator, but one completely integrated with the mining fleet. The excavator talks to the Komatsu haul trucks. Its operational data flows seamlessly into the same fleet management platform as the dozers and drills. This system integration is increasingly important. Komatsu's breadth creates a competitive advantage that pure excavator manufacturers cannot replicate. Finally, the machine's structural engineering reflects lessons learned from earlier deployments, producing insights about fatigue failure modes to fundamentally improve its design. The Komatsu PC8000 has an operating weight of approximately 800 metric tons, the same class as the Hitachi EX8000 and the Liebherr R9800. The convergence of operating weights in the 800-ton range reflects the physical and economic optimum that caused haul trucks to converge on 363 metric ton payloads. The constraints, tire technology, structural weight management, and hydraulic capacity intersect here to define the practical optimum for large-scale mining applications. The bucket capacity ranges from 40 to 52 cubic meters. The specific configuration selected reflects the material density and fragmentation characteristics of the application. Komatsu offers multiple bucket designs optimized for different materials, from standard rock buckets to high-capacity designs for lower-density coal and soft rock. 2 diesel engines power the PC8000, with a combined output of 3,000 to 3,500 horsepower, consistent with the class standard. These engines drive the hydraulic system at pressures up to 350 bar. The cooling system is sized for sustained full-load operation in high ambient temperature conditions. Where the PC8000 differentiates itself is in the hydraulic system, which manages power distribution between the machine's working functions for maximum efficiency. The load-sensing architecture continuously matches pump output to actual demand, reducing fuel consumption during partial loads while maintaining full power at maximum output. The electronic control system is integrated with Komatsu's Comtrax Plus telematics platform, the same platform used across Komatsu's entire mining range. Operational data, cycle times, payload, and fuel consumption flows into an integrated dashboard, identifying system-level bottlenecks that other systems cannot reveal. With integrated Comtrax Plus data, mine managers can identify if a production constraint is in the loading step, haulage step, or their interaction. The Comtrax Plus integration also supports predictive maintenance. Monitoring centers analyze data in real time to identify developing issues before they cause failures. Komatsu's scale allows them to recognize failure signatures across the entire population of PC8000 units, providing a reliability advantage that compounds over time. The structural engineering of the PC8000 reflects lessons that Komatsu learned from earlier generations of large hydraulic excavators. Lessons about where fatigue failures originate, how they propagate, and what structural design interventions most effectively prevent them. These lessons were also learned from the broader industry experience with ultra-large hydraulic excavators, including early O&K and Bucyrus machines. The main frame is the most critical structural element on the machine. It is fabricated from high-strength, low-alloy steel plate. Welding procedures minimize residual stress in the heat-affected zones. Specific steel alloys are selected for their combination of strength and toughness. Weld procedures include post-weld heat treatment at critical joints, reducing residual stress and significantly extending fatigue life. The boom and stick are box section structures. Their geometry is optimized for the working envelope while maintaining even stress distribution. Stress concentrations are minimized through careful design, large radii at corners, gradual cross-section changes, and avoiding parallel weld lines. The swing bearing supports the upper structure and allows it to rotate. It must maintain accuracy through millions of operating cycles. Komatsu's design reflects choices about bearing geometry, seal design, and lubrication that have been refined through decades of experience. The crawler undercarriage uses sealed and lubricated track links, similar to those used in Komatsu's large bulldozers. The ground pressure is kept within limits to avoid settlement of the mine floor while providing sufficient stability for facework. Applying finite element analysis to the complete system revealed interaction effects that component-level analysis had not shown. These discoveries led to specific structural reinforcements, adding material only where needed rather than uniformly. Field experience has validated these predictions. The PC8000's structural maintenance record is consistent with the analytical predictions. This confirms that Komatsu's structural design process can be relied upon for future machines as well as the current one. The PC8000 is most competitive in operations that already run Komatsu haul trucks, like the 980E and other Komatsu mining equipment. In these operations, the system integration advantages that Komatsu's common platform provides are fully accessible. The ComTrax Plus fleet management integration and predictive maintenance service are maximized when the complete fleet is Komatsu. The common dealer network and operator training programs cover both excavators and trucks, simplifying the entire infrastructure. In mixed fleets with Caterpillar or Liebherr equipment, the PC8000's integration advantages are only partially realized. The ComTrax Plus data and predictive maintenance still apply to the PC8000, but system-level optimization is not fully available. Achieving full integration across multi-brand fleets requires data integration efforts that often add complexity and cost. The trend toward standardization, reducing equipment brands to simplify maintenance and logistics, benefits Komatsu's strategy. As operations standardize, Komatsu's complete product range makes it a compelling single-vendor option. Meeting all requirements, trucks, excavators, dozers, and drills, from one manufacturer gains maintenance simplicity and training efficiency. Komatsu has been explicit about this complete system strategy in its marketing and product development investments. The PC8000, 980E, and D575A are positioned as components of a complete mining system, not just individual machines. Sales now involve modeling the complete mine system to optimize fleet composition for minimum cost per ton. This system-level approach is possible because Komatsu has the breadth of products to offer a complete, optimized solution. Operators understand that the best individual machines do not necessarily produce the best overall mining system. The PC8000's design, including ComTrax Plus and common platform alignment, reflects this strategic context. It is designed to be both the best excavator in its class and the most fully integrated machine in a Komatsu system. Both objectives serve the same engineering goals and contribute to the machine's global commercial success. The Komatsu PC8000 represents the current state of the art in Komatsu's large hydraulic excavator development. Like all machines in this series, its future development will be shaped by autonomy, electrification, and digitalization, transforming every category of mining equipment. Autonomous excavator operation is an active area of development at Komatsu. The challenges are substantial. An excavator operating in a dynamic environment is a more complex autonomous control problem than an autonomous haul truck following a defined route. But the technology trajectory is clear, and Komatsu's investment in autonomous systems across its complete product range is accelerating the development timeline. The integration of the PC8000 with Komatsu's AHS haul truck platforms creates specific opportunities for autonomous excavator-truck interaction. When both are under coordinated autonomous control, the loading process can be optimized at a system level, trucks arriving precisely when needed. The excavator's swing and dump sequence is coordinated with the truck's positioning to minimize loading time and optimize payload consistently. This level of coordination is not achievable with human operators. It becomes possible when both are under coordinated autonomous control. The electrification path for the PC8000, transitioning to fully battery electric or trolley-assisted operation, follows the trajectory of other large mining equipment. The energy demands are substantial, but the direction is established, and Komatsu's investment in electric drive technology will be extended to its large excavators. The PC8000's development history demonstrates the value of continuous, disciplined engineering improvement, no single dramatic innovation but continuous refinement, producing a machine that is more capable, more reliable, and more economical than its predecessors, while maintaining proven fundamental architecture. That approach is characteristically Komatsu. At 800 metric tons, it produces results that speak for themselves in the world's hardest mines. The PC8000, Komatsu's answer to the hardest mining challenge on Earth, a clear statement about the future of surface mining excavation. Next, we move to the Terex MT6300. A machine that challenged the dominance of the industry leaders with a diesel mechanical drivetrain. A machine whose engineering story reflects the audacious decision to take the road not taken. We are just getting started.